Welcome back to my channel. I'm going to show you how to set up the lab that we did today in class. The breakdown of hydrogen peroxide by our enzyme that we use, which is our potato. So of course hydrogen peroxide was the substrate. It's broken down into water and also oxygen. And how we will know that oxygen is formed, we'll start to see bubbles. And again, the bubbles come from the gas that is produced from the oxygen. You got to think about it. If you have an open cut and you put some peroxide on the cut, it starts to bubble up. And that just lets you know that, again, that hydrogen peroxide is being broken down into water and also oxygen. So let's look at the setup. So basically this is what we did. Just for the sake of this demonstration, I'm only going to show you 3 graduated cylinders, but today in class we actually used 4 for this lab. So, and I saw this, I got this, what I saw initially, and I'll put the picture in the video, was I'm in one of these like little groups. Again, always join these groups that they have on Facebook, these teacher groups, and one of the teachers in the group had a big size potato piece, and they also had a smaller piece, and they let it sit in the hydrogen peroxide, and of course it created bubbles, but it got me to thinking about surface area and volume. So since we just started covering that in class, I felt it was good to incorporate surface area and volume with this lab, and also take a look back as a refresher for enzyme and what enzymes do for reactions. They speed up reactions. So again, the hydrogen peroxide, what I said earlier, is going to break down into water and oxygen, and it will do it over its own, but it has to overcome the energy barrier to start making those products. Again, enzymes, they speed it up, they just let it happen a lot faster. So I asked my supervisor, I sent him those pictures, I asked him could he come up with something for this lab, and he sent me over really within the next couple of hours a good lab write-up. So I just kind of modified it just a little bit. I looked at one of the videos that I saw on YouTube, so I kind of blended those two together, and this is what I came up with. So what I already did maybe about 10 minutes ago was I cut a potato, so you can see the little cubes that the potato is cut in. So I cut the potato into these little cubes, and I measured them. They're about 1 centimeter by 1 centimeter by 1 centimeter, and I have 3 of those same cubes. So that's cube 1, this is cube 2, and then here's cube 3. Make sure they're the same size. So next what we did was left cube 1 alone. For cube 2, what I'm going to do is cut that in half. I'm going to cut it straight down the middle in half. So taking cube 2, which is here, and just making a cut down the middle. Okay, and a good rule of thumb, what you could do before you even cut, even though you're measuring 1 centimeter by 1 centimeter by 1, it's also weigh these to make sure they are the same weight. So I took cube 2 and I cut it in half. So again, this is cube 2 that has been cut in half. And then cube 3, I'm going to cut in quarters. Lord knows I need some lotion. I just finished washing my hands to get this potato stuff off my hands and put lotion on. Alright, so I have 4 different pieces that I cut it into here. Alright, so again, cube 1 is left whole, cube 2 cut in half, and then cube 3 cut in quarters. And then in class, what we did, we cut cube 4 in eighths, but I'm not gonna do that today. So to set this up, basically, I'm just getting extra water from out of these because I had to wash them out. So basically, what you want to do first, it's take, and I like to pre-measure about 30 milliliters of hydrogen peroxide. And of course, you want to pour this on the table so that you can read the meniscus. So that's about 30 milliliters I've pre-measured it here. So to each one of these graduated cylinders, I'm going to add about 10 milliliters of hydrogen peroxide. Okay, so that's 10 there. And I'm going to add 10 in this other one. And again, you should be reading these at eye level, which means I probably should be down a little bit more, but I can see it. And really, I should be able to just pour the rest in here if I measured out my 30 accurately. Alright, so basically what you want to do next is I like to add a small drop of dish detergent to each graduated cylinder. So I just put some dish detergent into this little beaker here. And I always use Dawn for some reason. Dawn is a lifesaver to me. So I'm going to suction it up. And to each of these, I'm just going to add 1 drop. And what I want you to notice is that even though I'm putting the drop in here, so there's 1, here's a drop there, and then here's a drop there. Okay, I want you to make a quick observation. Notice that they are not bubbling yet. So again, what I said, the hydrogen peroxide should technically break down and produce water and oxygen. So notice that it's not producing it yet. Still has not overcame that energy barrier to produce it. So we're going to use the enzyme just to speed this up a little bit. How will we know that oxygen is being produced? Again, it's going to foam up and start to bubble. So what I'm going to do first, this first one that we cut in half, I'm going to drop this in at time 0. And this whole thing is going to last about 5 minutes. So it's not going to be long at all. So I'm going to drop it in at time 0. 30 seconds after that, the one I cut in quarters, the 4 pieces, I'm going to put in here. 30 seconds after that, the one I cut in eighths, I'm going to put in here. Okay? So we're going to start the time in about 5 seconds. All right, here we go again. Take a while to get that one out, but it'll come. Alright, so I'm going to wait another 30 seconds and then I'll put the other one in. And you should start to see bubbles. So I already see them. So that means that the enzyme is helping this reaction to proceed. So a little bit more than 30 seconds. It's about 33 seconds. I put that one in. So that was the one in quarters. And then next we're going to have the one that we cut in eighths. Alright, and it's about 30 seconds now. So I'm going to drop that. Okay, and the reason I wait 30 seconds, because at the end, we're going to measure the height of the bubbles, how high it went. So I want to give us time to actually measure that. So we have about 3 minutes, 30 seconds left with each. You can see that the reaction is occurring. I'll bring this just a little bit closer for you to see, and you can see the bubbles. And what I've noticed with the one that's in eighths, it's about caught up with the other ones already. Okay, so again, I said that one should be happening a lot faster because we we've increased the surface area to volume ratio by reducing the size of the potato. Okay, and while we're waiting, this is just another extension that I do. Now, this I've had sitting all day. And this is just a graduated cylinder with the potatoes in it, the hydrogen peroxide, and a balloon. I put just a little balloon on top of it. And again, the oxygen gas that was produced was able to blow up the balloon. So the same setup, I did nothing different, but the gas was used to actually blow up the balloon. And that's just another extension, something you could do and see which balloon gets the biggest. You can actually measure the circumference of that balloon. Okay, so we have a little under 2 minutes left, and then we will record the height of the bubbles, and hopefully we have that amount of time, because that one that we cut in eighths is just growing and growing and growing. I hope it does not go past the amount of volume that we have in that graduated cylinder, or the size of it. All right, about 1 more minute. Oh man, y'all see this one right here that we put the 8 pieces in? It's all right at the top. All right, 30 seconds for that first one. And this one I know is going to go past it. Oh my gosh. We still have about another minute and a half on that one. About a whole nother minute. Alright, so we're at the first 5 minutes. So I'm going to measure the height in centimeters, starting from the bottom of the bubbles to the top. And this one is about 9.4 centimeters for that first one that we cut in half. Okay, and just so you can see it, this is what that produced. Alright, the one we cut in quarters is up next. I have about 3 seconds. Alright, so the one in quarters is measuring about 12 centimeters. And this is what this one looks like. And then the last one, I told you, and this one is all coming over top of the graduated cylinder. Have about 7 seconds. Alright, and this one, it's going to measure to be about, and again, I just do it from the base. This one is about 15.3 centimeters. So you can see this one, the one in eighths, was the largest. It produced the largest amount of bubbles. So this is what this one looks like. You can see again, and I'll show you all three side by side, that one displaced, or not displaced, but it had the most amount of bubbles. Okay, so let me put it here so y'all also see there. So welcome back. I hope you all enjoyed that lab. It's very simple, and it yields great results, as you can see. A couple of things, you just want to make sure you are following the safety rules. So you want to make sure you wear goggles, probably put something on to protect your hands, as well as some type of apron or lab coat. So you want to make sure you are following the safety rules, which I did not. But please make sure you and your students will follow. Additionally, if you want the write-up that I did, then just subscribe and I can get that write-up sent to you. And if you have any questions, just drop those down below. Thanks.
Ooh, baby.